Now after the session.
Okay, so you'll tell me when and we'll...
Yeah, sure. Uh, I welcome you all for this Azure Developer Community meetup on MLOps. And trust me, it's not about ML being hyped into that extent where you're understanding the complexity of developing an architecture or else a neural network that you can see as a piece of a paper which is having some sort of a neurons which are mapped and which are supposed to be trained. I think ML ops is something which everybody needs to understand, that it's all about getting this production system into the hands of all the developers, where everybody has an access to the insights and the intent which this machine learning model is. So now I'm with Yaran Habib, and this is our humble attempt in order to understand what is this technology all about. And on this series of sessions that we'll be doing on machine learning or else other technology, we'll be calling experts like Yaron and other guys will be coming up and giving their insights about this industry. So right now, this is our community page. It's azdev.community, and you guys can go there, check out what is happening and things like that. And what you get a chance is you get the chance to learn, network, and upskill yourself to be relevant in the industry. And every session will have a page like this, which will be popping up and saying that, hey, this is what sessions are going on now. And now you guys can click on the subscribe, and you guys can subscribe to all the events and the challenges which will be coming up from the Azure developer community. And you guys can just make sure that, okay, this is what it is. And also, if possible, try to give as many talks as you want, because I'm enjoying it as an organizer, and also I'm enjoying as a person who can do something, because I too never knew what was cloud exactly before joining AZDave, and now I am always into the cloud. Like, my perspectives are changed towards the technology. And now these are some of the upcoming sessions, so you guys can look at all the upcoming sessions which are being told here. So you guys can go here and say, okay, this is what the upcoming sessions are, and you guys can just register there. And also there are other events, there are partnering communities. Past events have also been listed here. You guys can join and you can see that. And there is a speaker bureau. And also, if possible, do join as a community organizer, where you are understanding, okay, this is where we are making a leverage of all the things that are available to us. And this is where you also can shine bright for your future. So uh, the stage is yours, sir. It's all yours, and you can give the talk now.
Sure. So thank you very much for inviting us, and so let's start with few slides, and then we'll. Sorry, let me just open the right presentation. Okay, so let's first understand the challenges, and then we'll also do a demo of how to essentially apply MLOps
Sir, can
using
you
Azure
go full
ML
screen?
tools and MLRun, which is an open source tool developed by Iguazio. Sorry.
Sir, can you go full screen?
Okay, do you see my screen?
Yes.
Okay, do you see my screen?
Yes, yes. Yes, sir. Yes,
And
we can
you
see your
hear
screen.
me okay now?
Yes,
I don't
yes.
hear you.
Yes, sir. We both can hear you.
Do you hear me? Do you hear my voice?
Yes.
Oh, okay. Anyway, so we're going to speak about Azure ML and MLRun and how they work together to achieve operationalization of machine learning. But let's start with understanding the problems in that space. Okay. So first, we're going to cover what is MLRun, and we're going to understand the problems, and then we'll show a live demo of integrating the different tools together. So with that, the first challenge that we stumble into is when we build machine learning, most of our time is currently spent on the development of the models. So we take data from offline sources, we extract them from CSVs, Parquet file, etc., from different sources. And then we run all sorts of analysis and training using our notebooks usually. We evaluate those and we keep on iterating over that. At a certain point, we need to build production pipelines that bring value to the business. The challenge is that when you move to a production pipeline, it usually looks very different. It requires attaching to online databases and online streams and event logs. It requires doing analysis at scale on an ongoing fashion, not only take a CSV or a Parquet, but extract data, do analysis, build a model, and then over time retrain the model, build new models, because we have drifting of our solution. We want to guarantee that the models keeps accurate. And this usually involves a lot of engineering. So most of the AI projects don't get to that phase of full operational pipelines, because it's usually a lot of engineering work beyond the work of a data scientist. And we're going to speak about it. And there are many other challenges involved in turning a project which started as building a model with some experimental data or data extractions into production. There are a lot of challenges. First, the way that we work between different teams. DevOps, data engineers, data scientists have different tools, different disciplines, and they don't collaborate, which makes things really hard. The second is that building something to production is a very long and tedious process. Also, accessing data in offline is one thing, but accessing the same features in online, accessing the features or building the features from the actual production data, the actual transaction data, is much, much harder than taking a CSV snapshot and working off of it. And also, we need to be aware that models lose accuracy over time because the data drifts, the concept drifts, and so on. So we need to keep on tracking the models and be able to remediate the problems by in retraining or changing the data and so on. So usually, people start the development work using notebooks or some IDE environments. But obviously, when you go to production, you can't just run your training or your surveying or your data integration or preparation logic inside the notebook. You have to operationalize it in a more of a modern microservice environment, like containers or serverless functions, etc. And that is something that in most cases require refactoring. So people will take the notebook, will take all the code from the notebook, put it in Python files. They'll add unit testing and so on, add performance optimizations, add security monitoring and logging, etc., to turn it into production data. You can't think of, okay, I have a notebook that's working, I've done most of the work. Actually, it's only the beginning of the journey when you have some sample code working in the notebook. In order to really productize a solution, you need many different components that are spanning the data layers, the machine learning and deep learning and training and serving and monitoring and so on. And it's really very, very hard to determine how to build a cohesive solution from so many disparate components that are usually not used to talk to each other. So this is really where we had the motivation of building an open source framework that orchestrates the different tools and build the glue layer. So it takes the best in class components from the different open source projects and glue it together as one cohesive solution, and also uses cloud services where it makes sense. Sometimes you don't want to go and install open source solution. You want something that just works and you can rely on. This is what we have Azure Cloud Services for. So if we look into, okay, how do we build a complete solution for machine learning for the different phases, and we're going to dive deeper into that. Then on one end, we need computation and storage. So computation and storage, elastic computation and storage is best achieved using things like Kubernetes or managed databases and managed storage like Azure Blob Store. So this is the underlying layer of the infrastructure for the entire solution. Is essentially Kubernetes for running the containers, storage, and virtual machines in the Azure space. On top of it, essentially, we have the parts of building the data, building the features that are going to be used for the different aspects of our machine learning work, the training, the serving, the governance, and so on. So this is really where you need a feature store. Feature store is a modern concept of essentially cataloging all your features, but also maintaining the pipelines, building those operational pipelines that build the features in from online data, from production data. So this is where MLRun has an open source feature store, and it can connect to different data sources, also streaming and Azure Synapse Analytics, which is more of an ETL data integration tool, Azure Data Lake, and so on. So this is the data part, and even within the data part, we still have a notion of exploration and design. Someone can open the Jupyter or a managed Jupyter as part of the Azure ML designer framework and just work against those features. At the same point, once we have the data, we want to run two different types of workload. One is the training workload, and the other one is the serving workload. So the training workload, this is really where we can use Azure ML, which has a lot of built-in auto ML. So we can take the pre-built algorithms in Azure ML and just launch them with a data set and let them produce the model. But once you want to serve the model, you need a serving framework that can build operational pipelines. The operational pipeline is not just serving a model, creating an endpoint that responds with a result. An operational pipeline also means, feature engineering, data enrichment, sometimes ensembles, sometimes more sophisticated topologies, especially if you're doing NLP or deep learning. You have to do different transformations on the data, anomaly detection, etc. So this is really where MLRun serving or using an open source serverless engine called Nucleo underneath shines. It's essentially an engine designed for building complex computation graphs in a serverless way and doing it in very high performance, and has built-in capabilities for machine learning, like drift analysis, model monitoring, and advanced primitives for data analytics and machine learning. So this is really where you're going to use MLRun that's going to take the Azure ML models and build and serve those models. You may need also other components like applying automation. So this is where you can use different CI/CD tools like Azure DevOps or GitHub Actions in order to build more automation around the solution. So that's a general view of how to build a stack. If we look at it from a different perspective, we need to think about what is an operational pipeline, something that keeps on working. It's like an engine. It's like a production line that always is always on. It takes data, it transforms the data, it serves model, monitors the model, launches retraining jobs, and so on. So this is the blue layer. Most people don't really think about it. They think about it after the fact. Most people focus on the yellow layer, which is the development of the model. So we need to keep the interaction between the production pipeline, where things are running, gathering data from production data, transforming it, serving models, monitoring models, retraining models, and so on, and the different development tools. So really, this is where MLRun and Iguazio shine is on building the production pipelines and also integrating with different Azure tools, and where you can use other development-oriented tools that are part of the Azure portfolio, as for BI and data exploration, for feature engineering or ETLs. You have Azure Synapse Analytics. For managed notebooks or designers, you have Azure ML Designer. For training, you have the Azure AutoML frameworks with built into the Azure ML. And again, you have CI/CD frameworks, whether it's Azure tools like GitHub Actions or Azure DevOps, and there are also other tools in the Azure portfolio for data governance, data quality, and so on. So this is where essentially what Iguazio and MLRun brings is the ability to build production pipelines off of all of those different tools that build the assets that we're going to use, whether it's data engineering assets or machine learning or monitoring assets. Now, why is it so complicated to build those production pipelines? Because it's not just like writing a piece of code and running it. There are many different steps in putting stuff in a production pipeline. So first, we need to take the pieces of code and package them in containers, in microservices, with different dependencies and so on. Second is we need to address scaling, because when we write a piece of logic in Python, it doesn't mean that it can work in 1,000 events per second or works on terabytes of data and so on, or build models that are very complicated. We have to be able to write the code and then figure out how to write it more optimally for scaling out, for distribution, and also in a very performance efficient way, because if we just go and run a SQL query every time we want a feature, we can do maybe one event per second, or serve one request per second, or usually less. But if we want to build a website that responds with recommendations to users and need to react in like 1,000 events per second, or and so on, we have to build the software efficiently with parallelism, sometimes adding GPUs, applying caching technologies and querying optimizations and so on, in order to make it really work without necessarily breaking the bank and using enormous amount of resources. Also, for production, it's very important to build instrumentation. So we know where we have problems. We need logging, we need monitoring, we have to have security, versioning of everything that we do, and apply automation. So every time we want to launch a new version, we know how to keep in sync the old version and the new version, and do rolling upgrades, build the workflows, build the reporting systems, and so on. Now, this usually people underestimate the effort. Usually, most of the effort in machine learning is about the productization, this part. You can develop a model using today's tool and AutoML in a matter of weeks, but putting this thing into a production pipeline that involves the data processing, the serving, and monitoring, and so on, it could take up to a year. And there's actually a use case that was published by Microsoft and Iguazio with Ecolab, one of our joint customers, where they reduced the time to deliver projects from a year to 30 days by applying those MLOps technologies. And one of the tricks to essentially move in that direction is, instead of thinking of the world of virtual machines or even containers, think of the world in terms of functions or serverless functions. I want to do something, I just want to develop a function and let someone else handle its scaling, its rolling upgrades, its security, and so on. This is really what we're trying to do. Now, there are serverless functions in different products, from Amazon, from Azure, but most of them are not designed for the work of data analytics and machine learning workloads, which are much heavier, they're more stateful, they're more high performance, high concurrency. And this is really where MLRun shines, is ability to produce is essentially serverless technologies that are designed for data analytics and machine learning. And I'm going to show you in a minute how essentially you build all those pipelines with using the MLRun function. So what is MLRun? MLRun is an open source project. You can see that in the link here and in GitHub. And it has several layers. The first layer is all the data processing aspects of a feature store. And we're going to see in a minute what does it mean. It means that essentially we can build features and store them along with the recipe of how to produce those features. So next time we want to produce the features, we don't have to go and do all the manual work. Just say go generate features, and it will go to the different data assets. It will transform the data and build it. The other thing that it does, it also keeps two copies of the data, one which is designed for the online production data, real-time features, and others that are stored for training, and as well as also deep analysis of the features for the governance and the monitoring. So the first layer is the feature store. The second layer is all those micro engines that know how to take a workload and distribute it automatically without applying any manual work, transitioning a piece of code into a scalable service And so this is really where the serverless engines come into play. And then there are other automation pieces of the data ingestion and the training, etc. In some cases, it's really wrapping the Azure ML service, allowing you to essentially launch it in an easy way to do some auto ML training, getting back the model and plugging it into the pipeline. So this is really where MLRun is fitting. And another thing about the MLRun philosophy, what we've seen from a lot of users in machine learning is there's usually a refactoring process. You build a nice notebook, you never take that notebook to production. Some brave guys tried, it's not advised. You need to essentially turn this notebook or pieces of it into production code that could be containerized and scaled and performed and monitored, etc. And in most organizations, that is essentially a full refactor. You take the notebook, you refactor it into new code, and then you build something production out of it. And this is something we're trying to avoid. We're trying to essentially let you build with your native tools, whether it's a notebook or an IDE like VS Code or PyCharm, and from within your development environment, with a single command, essentially transition that code into a production artifact, production service. And also, with a couple of lines of code, build a full pipeline by composing different built-in elements as well as custom elements and building the workflow for either the training or the or the serving pipelines. So you can essentially go and implement a function, save it, and then plug it in multiple workflows. And the last piece is we want to automatically essentially monitor everything and analyze the drift and all of those things and be able to react and retrain or change things in the operational pipeline to meet the demand. So this is the philosophy of MLRun. And again, one of the core things in MLRun is this concept of high heavy-duty serverless functions designed for machine learning and analytics. So the way that they work, you essentially give them a piece of code, and they build a fully managed service for you with full elasticity, security logging, monitoring, auto scaling, and so on. And in many cases, because of their unique design, which is very HPC oriented, high performance oriented, preserving memory allocations, garbage collections, parallelism, etc., those functions know how to accelerate your workload. So unlike some function technologies where usually functions will be slower than implementing your own container, in the case of Nucleo and MLRun, sort of the engines used for the serverless functions here, it can actually be sometimes 20 times faster with the same resources, with the same code, just by optimizing your code through different high-performance techniques. Now, when you build those functions, you can actually store them in a marketplace and reuse them in pipelines, as we mentioned. We're going to see that in a minute. And also, we mentioned that the functions are horizontally scaling and stateful. That means that we can actually run a workload. Let's assume we want to run deep learning, and one container or one GPU is not enough. We can say, you know what, give me 10 containers, 10 GPUs to run my training job without modifying a single line of code. We're not going to show it today, but anyone interested, we have a nice demo showing how you can take a workload and just scale it out without modifying a single line of your code. So that's, again, very powerful. And the way that it works with those function engines, that you have another interesting side effect, that every time you run something, it auto-records everything that goes in and out. So you can even get the experiment tracking, the data lineage, all of that is recorded automatically, everything that goes in and out of those functions. And that includes different engines that run the functions like Spark and Azure ML and Nucleo, etc., which is Azure ML is essentially an abstract service here as well, and we're going to see how it works. Okay, so let's start with how do we build a production pipeline. So essentially it has 3 steps in the process. The first step is the data collection and preparation. We want to do machine learning, we need data, and we need the data processed as features. Features is meaning that we may need to aggregate, we may need to join data, we may need to encode, do one-hot encodings, do all sorts of transformation to make the data ready for the training. So here we need a process of first we need to acquire data from different raw data sources. Then we need to apply feature engineering. We need to catalog the features, and finally we need different patterns of access to the same features. For training, we may need batch access. For serving, we may need real-time access. For governance, we need all sorts of statistical access to the features. So again, this is what we really need for analyzing features. And the trend today is to have something called a feature store, which is really doing all those different steps that we mentioned. There are some feature stores today Amazon has a feature store, Google has a feature store, very basic functionality. In Azure, essentially, Guazio has a feature store, which is a fully managed service in Azure, but it's also open source, and you could use it as an open source, and it integrates with Azure ML. And by the way, it's also a lot more advanced than the built-in feature stores for Amazon and for Google, because it has advanced transformation logic and a few other very powerful features. So the general idea is that I could define what is my transformation logic for building features using my code. We'll see that in a minute, or using user interface. Once I'm doing it, it will generate the features for me for real time or for training. I can version the features, I can search the features, I can learn information about the features. All that is happening automatically. And then when I want to train a job, I could just go to a catalog, select the features that I need, and translate them into a data frame or something, and run training, or get them as an online service, so I can run the serving directly off of those features. So that's a general idea of a feature store. Once we generated the feature, we need to build an automated development pipeline. So usually start with some exploratory data analysis, taking the features, building the features, and so on. In some cases, we want to select certain features, so we may want to analyze the data, the features, and reduce the amount of features we're going to use. Let's assume we have 100 features. It's hard to obtain 100 features in production, and it may not be fully necessary. Maybe 20 features provide us the same accuracy, and also inferring on 20 features will probably be faster. Our model will run faster. So in many cases, we want to do feature reduction or selection, and then we want to do model training. Sometimes it's even an iterative process. Then we do model evaluation, and if it's not good enough, we go back, we add data, we do training again, and so on. This is a place where you can actually use Azure ML or something complemented with MLRun capabilities to build those pipelines of obtaining data and eventually generating a tracked and a fully operational model. Okay, so that's the second phase. The third step is once we have those models, it's not enough. We can't just put those models behind an HTTP endpoint. It doesn't really help anyone because the live data doesn't look like the features we're pushing into that model. So usually in order to build a machine learning service, we need to build also a real-time pipeline, which has a sense of API. For example, sometimes we'll get an event as a JSON structure, or we'll get it from a stream, and so on. So we need to first take the event and have a secure API, and sometimes parse the data and so on. The second step we need to do is enrich the data. We're getting some customer ID, but we need to obtain a feature vector that has all the information about that customer so we can serve the model. So the second thing we need to do is enrichment. And then we want to do serving. And the serving may also be more complicated than a typical endpoint, because we may need to serve an ensemble as an example, or we may want to have a combination of models. Maybe we use an NLP model to classify some text, and then the classification result will go into a regression algorithm. So again, we may need to work with different models and combine them in different topologies. And once we've served the models, what do we do with the result? One way is to respond back to the HTTP request, but in many cases, we may need to push a notification to a stream where some other application will do something with it. respond to a client application, mobile application, or so. So this is all the area of how do you take the result of the model and push it into the application. But there's another path of sort of the feedback loop of getting the result and storing them, and also monitoring the results to identify if the model is behaving well, or writing the data back into the data lake so we can retrain the model later when we have accuracy problem or we need to have fresh models. So many people overlook the production pipeline, but this is also a very big challenge. It has to be always on. It needs to perform. This is another area where MLRun really shines. One of the ways that you could do it is just build a very simple Python description of a full production pipeline like this one, getting a request, doing enrichment, processing, maybe an ensemble of multiple models, maybe some more processing. You can develop it in your notebook with 2 lines of code. You can fully simulate the full operational pipeline in your notebook. In order to deliver that to production, you just say deploy, and that's it. So a single command will turn all that stuff that was tested and developed to an operational pipeline. And not only that it builds an operational pipeline, it also has built-in telemetry to track everything that you're doing. The models, the behaviors of the data going into the models, the drift analysis, accuracy problems, all that is real. There's real-time analysis of everything that happens with your serving pipelines. Okay, so with that, we can move into a demo. We'll move into so first, by the way, if anyone wants to learn more about MLRun, so you have mlrun.org, and inside MLRun you have lots of documentation on all the things that I mentioned. How to build distributed pipelines, how to build complex serving pipelines, how to work with the feature store, and so on. So this is again, everything is documented. There are many examples. This is like an NLP pipeline example. You can download the notebook and play with it. I'm building a fully production NLP, document processing with NLP and entity extraction, or building some other nice examples. So this is just to give you an overview of that. Now, let's look into the building a pipeline with I'm on the right place. So in order to build a pipeline, what we discuss is essentially 2 aspects. One is building the features, or creating the features that we have from our model. So this is like some heart disease data set that we may want to work with. And we may have the data lying around somewhere. So we can, this is just some sort of import, etc. And now we want to build a pipeline. So we can say, I want to do certain analysis on my heart disease problem. Take the heart disease data and do all sorts of transformations on that thing. Map certain values to age categories. Do one-hot encodings and do other transformations. So this is where we can logically build the feature engineering pipeline. We don't need a lot of feature, data engineers. We can just play around with this, build what we call the features, and then we could, just turn this operational pipeline on, and we're going to get those features as part of the feature catalog. Then, if we want to get the features and visualize them, we just go and grab the features, and we can see all the transformation we did. The mappings, the encodings. There are other pipelines that I showed you that are way more advanced. This is like a real-time fraud detection pipeline, with credit card transactions, and we may want to do all sorts of analysis on that credit card transactions. We want to do extracting of different data elements and time elements, mappings, encodings, aggregations, and so on. All this sort of complex pipeline that usually will take you like 3 months to productize, if not more. You could design in like 15 lines of code, and this is this entire pipeline. and just save it and simulate it and see this pipeline is producing exactly what I did. I can iterate over and over and save that data engineering pipeline. If you go into the MLRun dashboards, we can go to the feature store and see the different features that we've built, along with all their statistics and preview of the data and so on. So we can develop features, and then they're going into the catalog, and then from the catalog you could just select the features. The features could be for different entities, users, products, etc., and we can just go and build a feature vector off of those. And then when we build the feature vector, we can just go and train off of that feature vector. And this is really what we want to do in this example. Is we build a very simple pipeline. We turn it on. We build the feature vector. And then we can use that feature vector for a production pipeline. So in the production pipeline, we want to essentially use 3 different steps in our pipeline. The first step is we want to upload the features that we generate into Azure Blob Storage and register that as a data set for Azure ML, so Azure ML can run the training. Second thing we want to do is run a training job. And the training job is going to generate a model. The training job is going to run on Azure ML. Once we have the model, we want to create a real-time pipeline that will essentially serve the models. So this is where the concept of the serverless function comes into play. We already have 3 different serverless functions for building those things. So we can look at the code if we really want. So for example, submitting the training, we call Azure ML. There are different parameters that you can pass into those functions. And this is essentially going to submit the job in Azure ML and respond with a model along with all of the model telemetry data. So this is an example of a function that we built. And what MLRun Serverless Engine does is essentially knows how to turn this piece of code into a fully managed microservice for training or surveying or data engineering. So these are the 3 different steps, and then we can just go and build a pipeline. The pipeline is using a tool called Kubeflow. It's an open source project, which essentially can take those individual functions and turn them into a DAG, turn them into a pipeline. So we build a workflow for training. And when we have that workflow of training and generating the model and deploying it, we can actually trigger it later on. If we want to do retraining, we just trigger that pipeline, that workflow again. It will produce new models, etc. So we can put the triggering on a schedule or on other events. By designing that pipeline, it's relatively simple. This is a pipeline which comprises of 3 different functions. The first one uploads the features. So we give it all sorts of metadata around the experiment that we want and so on. The second one is training the job, and again giving it all sorts of Azure ML related data, the cluster we wanted to go push it into and so on. And once we have the model, we want to deploy the model into the MLRun serving framework. The nice thing here is that you can see that you can refer to different steps in the pipeline. So I ran training on Azure ML. So the output of the training is one of the outputs of the training is a model object. So I can just take the model object and put it in the serving side, and this will let MLRun know, okay, this is an object, what we call a data object or a data item. It will know that, oh, you know what, that model is actually running in Azure, and I need to fetch it in this way. And so here's all the metadata that belong to that model. So you don't need all the glue layer. You just need to pass pointer, or here we ran the training based on some feature vector. So that was generated in the first step. So we can, take the upload register dataset name that was generated in the first step and just use it as an input for the training. So we can build those pipelines and just execute them. And as we run those pipelines, I won't do it now because it takes like think like 7-8 minutes. But when you just say, run that pipeline, you essentially interactively update this widget here. You'll see the progress. But we have a simple pipeline of feature engineering and training, and then creating the model serving. And when the pipeline finishes, we can also see all the results of the models. Again, going back into our notebook. Behind the scene, what it's doing is essentially running this Kubeflow pipeline. This is a pipeline engine, open source again, that is going to be MLRun is going to create its a manifest and specification, run it, and track the result. And all the results are again going to be back into the MLRun framework. So I can see the different jobs running and all the results from the Azure jobs. I can see the logs of the process of that, and you can see the artifacts that were generated, the models, and which are stored on Azure Blob Store, and so on. And also I can see the actual model serving engine, which is running now in production, and I can see its code. It's doing some classification. I can connect it to a different triggering mechanism. For example, if I want to connect it to Azure Event Hub, I can just go and change the trigger to Event Hub or Kafka. So not only HTTP, we can support any form of invocation to access the model object. Now, if you go into Azure ML, you'll actually see that what it did, it launched an experiment here in Azure ML. It registered the data. So the heart disease data is registered in Azure ML using the first step that we mentioned. And then we ran the experiment. And when the experiment finished, we grabbed the model and placed it in the MLRun serving framework in order for it to run in production. And that's to show you what does it mean, a serving framework, serving function. Let's assume I want to serve, let's say, a scikit-learn model or a TensorFlow model. So I can build a simple classification class. By the way, you don't have to build it because there are already pre-baked classes for almost any common framework. But let's assume you want to do something more custom. So you build essentially a serving class. It has a load and a predict sort of methods as mandatory, but there are a few other optional like pre-processing, post-processing methods. And then I could define a graph. I can essentially define a topology where I'm saying, you know what, I want to use that model serving, but I want to have 3 different models with 3 different algorithms taken from the training, and build an ensemble, voting ensemble logic or something in front of it. So it will actually take the average results from all the 3 models and will respond with that. In order to test that, I create a simulator. I can place some data into the simulator and get the results visualized in my notebook. When I feel that my code is ready, the only thing I need to do is just say deploy, and it will deploy my model. Or the same deployment could be as part of this pipeline. As we mentioned here, see the deployment part is just one step of the pipeline, which is saying a deploy step, meaning this is not just it's not a run step. I'm not running a job and finishing. This is going to launch an online service that will keep staying there. That's why it's deploy step. So we can essentially go and deploy that model. And after we deploy the model, again, what we mentioned is that we have the full telemetry and monitoring. If I have some, there's full documentation on how the monitoring work. It's essentially doing stream processing on all the results of the model serving and doing analysis, which can be visualized in the MLRun user interface or in Grafana. We have some nice screenshots here. And these are the model monitoring in MLRun, and this is the model monitoring screen. So if I have an ensemble, I'll actually see all the different legs of the ensemble, and I can see which model within the ensemble has better performance than the other. So maybe I want to change the weights in my model serving, etc. So this is just, again, to give you the overall look. So what we've seen here is that we can build uh, relatively simple production pipeline by just taking those individual functions, and some of them are already built for you. The training function that I just showed, you don't really need to develop it because it's already a pre-baked function in MLRun. You just need to use it. You just need to import. Like if I'm going to take another, you can just import an MLRun function. You don't have to go and develop one. You see, in this case, I'm using a function from the marketplace, from the hub. Hub is like the MLRun function marketplace. So you can build your own functions and for training, for serving, for data integration, and then just plug them into different pipelines. Pipelines don't need to be as simple as what I showed you. Pipelines could also be a lot more advanced. Let's see if I have some other examples of a pipeline. You see, this is an example of slightly more sophisticated pipeline that have some CI elements, some data engineering, training, data analysis, model deployment testing. So after we deploy the model, we may want to run additional stress tests to verify that the model actually works, and so on. So this is a slightly more sophisticated model, but most of the functions here are pre-baked MLRun functions. That, like, the summary is a deep analysis function. Training could be again done in Azure ML, or there's a simple scikit-learn training functions, and so on. So this is in general, again, what we've seen. We can build pipelines that handle the entire flow for data engineering, for automated model development, for the production pipeline of listening on actual data and building the serving and the activities, as well as monitoring of everything using a relatively simple flow. So we don't, and the nice thing here is that, again, we can work with our native tools, with our IDEs, with our PyCharm, with our Jupyter. We let something else deal with all the build of the containers and the pipelines and all of that. You see, I haven't done anything here. I didn't build YAMLs and Dockers and containers. MLRun did all of that for me. The only thing I did, I just specified the Python file I'm going to use and potentially some sort of engine type. Again, there are different engine types like Spark or distributed deep learning engines and so on. Maybe I have some package requirements. I just specify those, and something else is actually building a fully managed service for me. As we've seen here, these are like fully managed services with telemetry, with everything that I can just run again and again. Everything has its full tracking of what it's doing, logging, monitoring. All the security is very hard, and so think about how much engineering work you usually apply to turn some piece of code in your notebook to like a production pipeline. Here, it's all done automatically for you. Okay, so with that, sort of concluded the demo part, and I assume there may be some questions that people want to ask.
Yeah, folks, any questions and any
I
queries
don't
to
hear you
ask?
well.
Folks, can you hear me now?
Let me-
Sure. I think, guys, any questions? Do drop it down in the comment section below.
Okay, I still don't hear you, but you can write maybe in the chat.
Yeah, wait. Can you hear me now? Fine. I think this is what.
I don't know why, but I don't hear. Let me try and
Sure.
refresh
I
maybe
think,
this thing.
yeah, Deepak, Kubernetes for ML orchestration, you can think of Kubeflow, which is always there for your help. And yeah, that's what it is all about. Like, when you are going for a deployment, I think Kubernetes also makes a sort of an sense here. So yes, sir. I think. Can you hear me now?
Uh,
Fine. Sir? Oh God.
Still can't hear you. I don't know. Do you hear me?
Yes.
Okay. So maybe you can write the questions down and I'll try and answer them. So the question is, are we using MLflow in the solution here? So MLRun has essentially an alternative way of doing what MLflow does. Uh, the MLflow is mostly for tracking. So you run a job and you can track the results. The problem is that you need to instrument all of that. In MLRun, it's an orchestrator, so it is launching the job for you. Because it's launching the job for you, it can automatically log all the information. So you actually get all the logging that you get from MLflow, but you also get all the operational data, like when did it run, on what machine, what was the CPU usage, etc., that MLflow cannot tell you, and also what was the Git version of the execution when it was running, etc. So MLRun has all the capabilities of MLflow, but it's integrated in a more holistic way with the orchestration, not just the monitoring. It has data lineage tracking. For example, when you're running a job and you have input data and output data, then essentially it's it will automatically track that, and it knows exactly like when a data was generated, which process was generating the data, and the reason that it knows all of that because it is launching the jobs on the computation, so know exactly all the information to build the tracking graphs. Um, and again, if you're using MLflow, you can still keep on using MLflow. It's just that you're going to have two solutions to do the same, because from MLRun, you're going to get it for free. Another example, for example, for deep learning, MLRun has essentially auto instrumentation of your code. So let's assume you have a TensorFlow job that you're running. Now you want that TensorFlow job to have tracking information in TensorBoard or in MLflow or MLRun, and you may need to do, and that's just the tracking. But then you also want to do checkpointing. You want to be able to do horizontal scaling using Horvath. You want to apply all sorts of callbacks for optimization, etc. So you end up having a lot of engineers build all that for you. In MLRun, it will do it automatically. So MLflows have some experimental work for tracking of deep learning, but it's only the tracking. It doesn't know how to instrument your code to suddenly horizontally scale. And MLRun will do both things in the same API call. It will essentially looks at your code, it puts the hooks for the tracking like MLflow, but also puts the hooks for checkpointing, recovery, security hardening, secret passing without credentials, auto scaling. So it's both aspects of orchestration and tracking in the same framework. So MLRun is using Kubernetes. Okay, the MLRun runs over Kubernetes. It's running over AKS. The problem is that if you're really a fan of YAMLs and containers, go ahead. I don't know a lot of data scientists that like to write YAML files and do Docker builds every time they change the code and integrate with Git, all that manually. This is what MLRun does for you. You're saying, here's my code, build a service for me. It's not just building the YAML and the Docker. What about health checks? What about the integration with Prometheus? What about logging and all of that stuff? So if you just use Kubernetes, you end up doing a lot of work. You've seen also Kubeflow integrated as part of the MLRun solution. MLRun and Kubeflow are very good friends, but you can say, okay, why not use Kubeflow? Exactly for the same reason. If you use Kubeflow by itself, so you end up writing YAMLs and you end up doing a lot of work that the data scientist will usually not do. Data science wants to open his notebook, play around with data, and when he feels it's ready, click on a button and make it run. And that's not the experience of Kubeflow or Kubernetes. Kubernetes is good for DevOps people, not for data scientists. And Kubernetes is a tool for you to build services on top of it. What MLRun is a service on top of Kubernetes to make it easy for the data engineers and data scientists, and by the way, DevOps people, to work. It will produce the logging and instrumentation needed for the DevOps people to track what went wrong. And I could tell you that a lot of things can go wrong in Kubernetes. So you ask about the type of languages. So we support about 7 different languages, but the most dominant one and well-tested one is Python, obviously. For areas of high performance, we usually also use Go functions to do, very like Nucleo serving in Go provides about 400,000 events per second on a single process. This is like, to compare it to like Amazon Lambda, it's about 100 or 200 times faster, just in terms of performance. Even in Python, it's producing about 60,000 events per second. It can process 60,000 events per second on a single process. So there are no other serverless engines that have this performance, and that's because of the built-in parallelism that is built into the processing engine. So you have the abstraction of a serverless engine, but the performance of something bare metal. Okay, is there any additional questions or? So actually, the interesting part that we've been working with a lot of organizations that don't have the full ML engineering practice or MLOps practice. Because very very large and established organization, like you go to a bank, they have 100 people just doing the ML engineering part beyond the data science. And if you are in a relatively medium small organization, then this is becoming a challenge because the data scientists don't know how to move to the next. Sometimes we get questions, okay, how do I deploy my model? And people don't really know how to do it because it's like they're used to work in a notebook. So we actually have today data scientists that do the deployment because it's so easy. Because it's a single call. It's just saying .deploy and it's deployed. They need to learn. There are a lot of tutorials, as I showed, that show how to do it. If they work with us directly, then we have also a services organization that usually work with the customer to teach them how to operation. We, in most cases, 90% of what we do with customers is not teaching them our products or our solution, is teaching them how to do the right engineering work and practices. Like spend an hour and a half yesterday with the customer teaching how to work with Git. Okay, nothing to do with us. Like what is a proper way of versioning your code and push and pull and commit and all of that. So so we're not using anything unique. What's unique about what we're doing is it's all open source, it's all open ecosystem, but we're trying to glue things together so the flow of moving to production is very continuous and very simple. Yeah, so this is a question. Can we merge the work of the data scientists and data engineers and DevOps? This is really the what you have to do. And we had a session with the head of data science in Ecolab, who is a very senior, very seasoned data scientist and also managing data science. So he was talking in that session really about the 3 phases that he evolved during his professional work, moving from the siloed work, where data scientists develop a notebook and then they throw it over the wall to a different group, and they keep ending up optimizing the model further and further. It will never get to production because these are separate teams, and even if they get the model to production, they need to change something, they need to re-engineer. No one has the time and energy to do it. So the only way to succeed is by having everyone working together on sort of a pipeline where a data scientist writes a piece of code, he versions that piece of code, is uses it in the pipeline. The data engineer will take the code, say, you know what, you forgot exception handling. You forgot some caching. Maybe you don't need to use that package, use a different package. He takes the same thing, he optimizes, he improves it. He saves a new version, version 2, which is better. Data scientist goes, he wants to do some other thing. He takes the second version, he's not taking the first version. He's going to do some extra work, add another feature or so, and save it. This is the only way to succeed and not waste too many resources in an organization. And you can read a case study of Ecolab and Azure, how they essentially reduced the time to production from 12 months to single months. And after they do it once, the second time is even easier. Why? Because they factored everything into individual functions. So the next project, they already have the components that 50% are reusable to the next project. And the third project, 80% of the components are reusable. So this brings you velocity. But it's really important that the organization, also from the political side, not just the engineering side, understand that the teams have to work and collaborate together, because otherwise you get stuck. Can we monitor models without ML for Kubeflow? Yes. So MLRun again has the monitoring. By the way, Kubeflow does not monitor models in production. It only monitors the pipeline, the batch pipeline, and MLRun does that through Kubeflow or without Kubeflow. You can even run in MLRun a pipeline without having to run it in Kubeflow. Kubeflow is one of the pipeline engines. We also support GitHub Actions, GitLab CI, and a bunch of other pipeline orchestrators, but it's all managed through MLRun, which is nice. So you have one place. You can even run it locally, the pipeline, debug it, put breakpoints, and then you want to move it to a cluster. One flip of a button, it runs on the cluster. So MLRun is not an alternative to Kubeflow. Kubeflow have different components. Has a managed notebook, has operators, and has pipelines. Managed notebook, we don't use it. Also, Azure has its own managed notebook. Kubeflow pipeline we use as an engine to orchestrate jobs. So MLRun will actually program Kubeflow, but it also will abstract it away from the data scientist. Data scientist doesn't need to understand the underlying details of Argo, the Kubeflow engine. And also the operators are essentially tools to build like TensorFlow jobs and things like that. So what MLRun does is it wraps the Kubeflow operators as a serverless function. So we have one of the operators is called MPI job, for example, in Kubeflow. It's a framework for distributed deep learning. But as I mentioned before, if you use MPI job, you need to build the YAMLs, you need to build the containers, you need to control the various containers that are part of the workload, the master, the worker. In MLRun, you just write the Python code, you add one line, and you get automatically all this. By the way, if you want, you run the job on a single container or on MPI job without changing the code. MLRun will automatically adjust the code to the operator that's being used. So essentially what MLRun does is a abstraction layer on top of Kubeflow. So it's not replacing Kubeflow or it's not competing with Kubeflow. It's just making the work with Kubeflow significantly simpler for people. Okay. So as I mentioned also before, there's a low code and no code solution because the functions, you can store them and save them. You've seen, I can show you other pipelines where there's no code at all. If you go to like the getting started, the thing example, there's no code because you have a function for training, you have a function for feature engineering, you have a function for serving, you just chain them. You just say, you know what, here's a data frame, run training, you get back a model. Okay, I have a model, go deploy the model. So usually if you are doing things like NLP or deep learning, you have to write some code because the neural network, but even there, we're trying to simplify that you only focus on the data science code and not on MLOps code. So the MLOps code will be instrumented automatically. And again, there's a lot of low code. There's also UI. You can build things in UI without actually going through a notebook. Yeah, so I think there's a point here that MLRun converts your Python function to serverless function and Kubeflow pipeline. Kubeflow pipeline is essentially, think of it as a DAG executor. It's essentially knows how to run step A and then step B and then step C or some order. So what we did in MLRun is that the steps are functions. So unlike traditional kubeflow where you need to orchestrate containers and all of that, in the kubeflow with MLRun, you just you launch functions. And one of the functions, by the way, could be training on Azure ML. So you can actually build kubeflow pipeline that executes Azure ML through MLRun. So it doesn't really have to be containers on the underlying layer. Okay, so anyone, by the way, you can reach me out in LinkedIn if you have any question, and we'd be glad to help any of you. If someone wants to test MLRun and play around with it, then again, it's open source. We can help you. We can even give you a test cluster on Azure that you can just we launch a cluster for you, and you play around with it within your own VPC or within our public VPC, so you can learn how to use it. So thank you for attending the session, and again, feel free to reach out to me.
Yeah, thank you so much, sir. Thank you so much for this amazing session. It was so nice that you could give us some insights for this MLOps and how to actually build some new thing out of what is available as a framework, what is available on our Jupyter notebook. Thank you so much. Yes.